Alright, welcome to Do You Know AGF? In today's video, we'll be treating a lot of things on longitude and latitude. Please, before I start, permit me to acknowledge the very person that was requested for this video. That's what, Star V. I know you would make it because even before there was announcement of the timetable, you've actually been appearing on our channel. Now, for this topic to be well understood, we would have to talk about what we mean by north, south, east, and also what? Also west. Now, to talk about that, I'm talking about north. We have the north here. Please try to understand this very fact. We have what? We have the south here as well. We have the east here, and we also have what? We also have the west. Now, with this, we can actually transfer that into this very sphere. So we have the what? We have the east here. We have the west here. We have the south here, and we would also have the what? The north here. Now, because we've understood this, I would like us to talk about latitude. I'm talking about the lines of latitude. They are lines that what? That run from west to east. Run from west to east. Run from west to east. Just like the lines you can see now, right now. We call these very lines of what? Latitude. Now, let's talk about what we mean by what? Longitude. When we're talking about longitude, so there are lines that what? That run from the what? The North Pole to the South Pole. You see, the lines you can see right now, they are lines of what? Longitude. Okay, I'm coming out. The lines you can see right now, they are what? They are lines of longitude. Now, get this. All the lines we've been talking about, the lines of longitude, the lines of latitude, they are what? They are imaginary lines. They are not real. They are just used to what? To locate points on the Earth's surface. I can actually locate where you are right now through the what? Through longitude and latitude. Now, I realize that most students do what? We do take longitude for latitude. So because you can, for you to understand this, what we are going to do now is to what? Is to use something for that very latitude. And I would like to what? Introduce what we mean by what? What we mean by flatitude. See, don't get me wrong. Oh, there's nothing like flatitude. But just for you to understand it, I'm talking about flat things. You know that what? There are things that what? That are flat. Just like you are talking about a flat surface right now. So with that, you can take that concept to what? To this very sphere as well. Check it. You see that what? The very line, the lines of longitude in this very place, they are what? They are flat lines. Do you see that what? They are run from the west to what? To the east. So just check this word very well. Flatitude. Now you see this very latitude as well. You see that what? Latitude. Now we've successfully described latitude and longitude. Now let's talk about how to locate points on the earth. But before then, I would like you to click the red subscribe button and also click the notification bell if you've not done that, so that you will receive more videos just like this. That red subscribe button is what? It's below this very video, and it's just for free. Now, to locate a point on the earth's surface, we have to name that very point something. It could be A, it could be B, it could be C, just toward Z. Now, what I would like you to understand by this is this. Just where you are seated right now, watching this very video, you can name that very point what? Point A. So we'll start with that very point. We would write A. Now, after that very A, I talked about longitude the other time and I talked about latitude. And these are the terms that are being used to what? To locate a point on the earth. So we would start with what? Latitude. We would write the latitude here. If it is 50 degrees north, if it is 50 degrees south, if it is anything north-south, we would write it here. That's the first thing we are going to write. Now, the next thing is what? We are going to write the longitude. That's what? It could be something degree east, something degree west, and things like that. We are going to write it there and what? Would close the very bracket. Now, this is it. Don't do a mistake of writing, though you might not be asked in Waec, but just understand this fact for us, for knowledge sake. Don't do a mistake of writing something like this. Right? We are trying to what? Locate our point. You write A, you now write longitude before latitude. No, it's very, very wrong. Now, I want you to understand this concept very well. Please take your time to understand this. Though I said the lines of what? Latitude, they run from what? West to east. But their angles are not named after west to east. So note that. And this is the reason. Okay, let me call this very line you can see here right now, this very line that goes to from west to east. Let me call the very line, it's not let me call, the very line is called the equator, because what, it divides that very sphere into two equal parts. So it is called the equator, and we are talking about the latitude of that very place. It's called 0 degrees. Do you understand? 0 degrees. So you can just say that very place is what? That very place is 0 degrees. Now, let me now take some other latitude that we have here. So some other lines of latitude that we have here. This one now that you can see here, you can actually name this one um 10 10 degrees north. 10 degrees towards the north. That's just the meaning. 10 degrees towards the north. Now, let's see another one here. This one, as it goes towards the north, as it's going towards the north, it's what, the name would be changing. Like the numbers, the degrees will be increasing. Just like this very 10 degrees now, you would have this one to be 25 degrees north, and like that until you get to what, 90 degrees north here. Until you get to try 90 degrees north here. Exactly the same way you did that very thing. You can also see this one also. This one also could be something like let me call this one also 10 degrees south, because what, it is towards the south. Just like you can see here, this is the south, right? So it's going towards the south from the equator of 0 degrees. So that will give us what, 10 degrees south. The other one you can see also, it could be something like 35 degrees south. 35 degrees south. And like that until you get to what, until you get to this very south, that will be what, 90 degrees south. Do you understand this very aspect? Because you need to understand this. Now, similarly, when we're talking about the longitude as well, you need to talk about the term prime meridian. That's what, that's the one you can see here. Prime meridian. It goes straight from what? It divides that very sphere into two equal parts. Though all the lines, no, please get this. All the lines of longitude divides the circle into what? Two equal, like divides the sphere into two equal parts. But we are talking about all the lines of latitude. They are not. They can't. It's not all of them that divides the what, the circle into two equal parts. We'll still talk about this later when we're talking about the small circle and the what, and the great circle. So now when we're talking about this, after you've actually known this very line, no, now towards the east, we need to talk about this towards the east now. No, I talked about it that the east is what, towards the right hand side. This very right hand side you can see here. So the east now, we are talking about this towards the east. This very place that we draw now, it could be 50, it could be 10 degrees east. So notice that. So that's what we call longitude. When you see something like east and west, we call it what? We call it a longitude. Like now, you see this very angle of longitude is what? 10 degrees east. Let's see another one. The one that what? That's next to it also could be something like 30 degrees east. It could be something like 30 degrees east. Just like that until the line will touch this very side, and we would call it also 90 degrees east. So we'll call that very line also 90 degrees east. Hope you've gotten this. Now let's talk about the west as well, because I want you to understand this very aspect. If you don't understand this very aspect, you might not get what I will be talking about later in this very video. Now, after we've done that, let's talk about the east. Now, this very east now, you see, we can actually what? We can actually draw a line here, right? That's the left of the what? Of the prime meridian. The left of that prime meridian, we can call that very side also to be what? To be something that we call 10 degrees west. The second one also, if I should do another one here, I can also call this very place. 30 degrees west. Though it will be measured, but it's because I can't actually measure it in this very video. So that's why I just want to do what? I just want to give an example until you get to this very side that you would call what? That you would call 90 degrees west. Hope someone has gotten me. Now, after you've understood that, you could actually be given a point to be what? To be like this very A now. So we could actually be given the latitude to be what? To be 50 degrees north, and then 30 degrees east. Then would have to close the bracket. But just note that this very thing, you could be given 2 points on the earth's surface, just like the point where you are seated now, and maybe the point where your plates are in the kitchen. So those plates, you can actually be given, they could be given 1 point. So you write the latitude and the longitude, and you also, you'll be given 1 point, the latitude and the longitude. So with that, you'll be able to what? You can actually know the distance between you and what? And your plates. Don't worry, in this video we'll still talk about more on that. So now let's talk about angles between what? Between 2 points. Just like you can see here, angles between 2 points. Now let me use this very A to be your room, and this very B to be your dad's shop. So the distance between that very place, you want to know it right now, and this is the what? This is the location of that very place. That's your room is what? 50 degrees north and 30 degrees east, and this very 50 this B is what? Is that your mom, your dad's shop. That's 50 degrees north and on 75 degrees east. So let's locate that on the globe. Okay, let's draw a globe. After we've drawn the globe, now the next thing is for us to what? Is to locate the midpoint. So after the midpoint here, you've located it, right? So the next thing we are going to do now is to what? Is to okay, you know, when we are talking about latitude, they run from what? The lines of latitude, they run from west towards to east, right? Do you remember when I was talking about flatitude the other time, so that you can what? Understand this concept. Now the latitude is what? 50 degrees north, right? So we have 50 degrees north as the latitude. That means it will be somewhere around this very north area. Do you understand? So let's just okay, let's draw the equator first. And now, so the line of latitude could be somewhere around this very side. So let's call that place 50 degrees what? 50 degrees north. 50 degrees north. Now, after we've done that, the next one here is what? We have 30 degrees east, right? So let me take another color. So 30 degrees east. Now, that means we are talking about what? Longitude, right? And I already told you that what? This is what we call east, and this is what we call what? We call this very place west. Now talking about the what? The 30 degrees east. Okay, let me talk about this very place first. That's the prime meridian, right? So it will be towards what? Towards the east. That's, let me say, these are 30 degrees east. Now we've done that 30 degree east, right? So don't forget the what? This very point as well. That's B. B is what? 50 degrees north, and you can see that we've already done 50 degrees north here. That means they are on the same latitude. Your room and what? Your dad's shop on the same latitude. Now the difference now is that what? The longitude is different. So now the longitude, let's locate 75 degrees east. Now to locate it, you know that what? As it approaches E, it will be what? The angle will be more. It will be larger. So now that means that what? You would have the 75 degrees east somewhere around this side. Now you actually seen that what? This very place is what? Is the 75, let me do it very well, 75 degrees east, right? And you've actually seen that what? This very the second one, let me use another color. The second one here, it's what? It's 30 degrees east, right? So after we've known that, the next thing is for us to calculate the distance. So now to calculate the distance, we have to look for the angle, right? So we look for the angle between this very longitude, because though your room and your dad's shop, it has the same what? It has the same latitude, but there is a difference in the longitude. So it is that difference that will use to what? To get the distance. Now what you will do now is to what? Is to this very place, you know, this is the line of your room, right? And this is the line of the longitude of your what? Of your daddy's room. So you locate everything, you push everything to what? To the center here. You would have, so the angle here will be the what? Will be the difference between the two. The angle here. Now I want to tell you this. If you are talking about the angle of what? Of things that are maybe like now, if you are trying to talk about east, just like you can see here now, we have what? 30 degree east here, and we also have 75 degree east here. So that means that what? We have to subtract. Just like you can see this very place now, you have to subtract it, because they are what? Just try to see this very place now. We have what? We have we have the first one to be what? To be 30, right? We have this one to be 30, and we also have this one also to be what? To be 75, the 75 degrees. Now, to look for the angle that is between them, we have to what? We have to subtract it, so that we look for the angle between this very 30 degrees east and what? And 75 degree east. So that means that the difference between this very angle would be what? Would be 45 degrees. Do you understand? Now, let me talk about another way round. So I just want to tell you that what? If you have something like east east, you have to subtract. If they are if the two what? If the two points, they are what? East east, you have to subtract. If they are west west, you have to subtract. Just like you can see here, we have east east. So you have to subtract them from each other. If you have north north, that's when there is difference in the latitude, and what? There is nothing like the difference in what? In the longitude. You have to what? You have to subtract. If you have like 50 Newton, 50 degree north and what? 35 degree north, you have to subtract. You have something like this you have the difference in what? In south as well, like something degree south, like 30 degrees south, and the second also is what? Something degree south, you have to subtract. But if you have different things, like now, if the longitude should be okay, let me give you this example. Let me call this very 75 degree east. Let me change it to west. So it will be what? Let's call it 75 degrees west. Do you understand? Now let's locate the point. Just like we said the other time, this is what? This is the prime meridian, and this very side will be what? This very side would be that's 30 degree east. Do you understand? Towards the east. Now this very place is what? Is the west, right? So towards the west here we have 75, right? 75 degrees. So you have something like 75 degrees around this very side. Do you understand? Now, the angle between them, to get this very angle between them, this is the what? This is the line of the latitude, right? This is the line of the latitude that you can see here. So we have to what? We have to trace this very line towards each longitude. And after that, we trace it to the center of that very sphere. Now, this is what we are going to do. To the center would be here. From this place to this place, that's for 75 degree east. And then from this place also to 75 degree west, and from this place also to this place for what? 75 degree what? 30 degree east. Now, if you check this very angle here, you see that what? It's what? It's more than the very angle we got the other time. So that means that what? This very place is larger. And with this, you should know that what? You have to add it. The angle here is what? The angle here is what? Okay, let me use another color so that you understand what I'm saying. Okay. The angle here is what? The angle here is what? It's 30 degrees. While the angle here also is what? The angle here is 75 degrees. So we have to add the two angles to get the total angle here. So that's why I was telling you the other time that what? If you have the same one, if you have the same, if you have east and west, if you have east and east, like the two parameters given, you have east and east there, that means you should what? You should subtract. But if you have east and west, you would what? You would add. Just like we have here, if we want to get the difference between this very what? Longitude, we have to what? We have to add them. Because what? We have west here and we also have east here. So if you actually want to get the difference between this very longitude now, it will be what? It will be 30 plus 75. That will be what? 105 degrees. Before I continue, please kindly subscribe. Click that red subscribe button and the notification you will see beside it. This will enable you to get our videos. I tell you, we will create more videos that will help you even after we've created this. For us to understand what I just said, these are some examples. If you want to talk about the difference between this very A and what and B, you will see that what they both have what the same latitude. This very 50 degrees south and 50 degrees south here. But talking about the longitude is 30 degrees east and 40 degrees. Wait, I want to ask you one question. Hope you guys are jotting all this very thing. No, don't just see. I want to tell you this. Because I just remember now. If you actually want to gain from online classes, I tell you, try to jot down everything you are actually watching. I'm telling you, that's the best way to learn. Now, after this 30 degrees east also, this very 30 degrees east also, you have to look for a difference, right? No, because we have east here and we have east here as well. What you just do is to subtract to get the difference. That's what the angle there will be what? 10 degrees. Now, talking about this very C as well, let's compare this very C with what? With A. Let's compare C with A. If you want to compare C with A, you will see that what? The same latitude as well. We have 50 degrees south here, and we also have what? 50 degrees south here. What you will just do here is for you to look at the what? The longitude. The longitude is what? 80 degrees west here, and we also have 30 degrees east here. Now, for you to get the what? The difference between this very longitude, what you would do is to what? Is to what? Add the two angles together, because what? You have east here and you also have west here. They are different. So you do what? 30 plus 80 would give you what? Will surely give you 110 degrees. Now, after we've done that, let's compare this D with what? With C. If you check this very D with C, you would realize that very D, this very D you can see here, and this very C here, the same latitude, like different latitude, but what? The same longitude. So you will leave what? You will leave what we mean by that longitude, because they are the same. So you look at the difference between their latitude. What is the difference between their latitude? It's what? We have 50 degrees south and we also have 30 degrees north. That means that what? That means that we have south and we have north. So they are what? North is south is not the same thing as north, right? So you have to what? You have to add. That will be 50 degrees plus 30 degrees, and that will give you 80 degrees. Now, the next one we have here is what? We have 30 degrees north, comma, like this very E, it's what? 30 degrees north and what? 80 degrees east. Now, if you compare this very D with E, you would realize that we have the same latitude here, we have the same latitude here, but what? We have different longitude here, and we have different longitude here. That's west and east, right? So we have to what? We have to add. That will be what? 160 degrees. I hope with this you should be able to understand how to get the angles between two places. Now, let's look at the next one here, which is what? How to calculate a point along the what? The great circle and the small circle. Now, let's talk about a small circle and a great circle. Please, I would like you to pay adequate attention at this very moment, so that you will understand this concept once and for all. Now, talking about the small circle and the great circle, I want to tell you that in the globe we have, in this very globe you can see on the screen right now, we have the small circles there and we have the big circles there. Now, talking about a line like this that goes from this very side to this very side, that goes from this very side to this very side. You know, I told you already that what? We call those lines the lines of what? Latitude. But there is one of this very line that would what? That would go through the center of the circle. Go through the center of this very globe to, okay, I'm sorry, I want to draw the center very well. I want to draw the center very well. That will go to this very center here. You see, it will go like this to this very side. It goes through the west and the south as well. Do you understand? If you check this very line, you will see that what? This very the line here, the line you can see here, the line you can see here, the length can't be compared with the line you can see here, right? And the length also can't be compared with the line you can see here. Exactly. So that's why we have small circles and we have great circles. And now, if we should divide this very, okay, the what? You know, you can actually divide the globe into two equal parts here. So that very side, you know, this very place should be the radius, and should be the what? Should be point here, right? And that place from this very side to this very side, from this very side to this very side, you would have the what? You would have what we call the radius. Do you understand? Now, and now let's check this very place also. This very side also. This very place to this very place. You see that what? The radius here will be what? It will be larger than the what? The radius at the what? At this very side. Do you understand? The radius here will be larger than this very side. So that's why we have the small circles and we also have the great circles. I just want to make this known to you that what? The lines of latitude. The lines of latitude, we have small circles throughout. But the only exception is what? Is the equator, because it goes through the center of that very globe. Do you understand? So that means the equator is what? This very equator here. Okay, let me write the name. This is the equator. Equator that passes through the center of that very circle. It passes through the center of the globe. This is the equator you can see here, the line you can see here. So that very equator, it's only the great circle you can see among the latitude. So that means we've actually gotten one great circle like that, right? Now, other circles, or like other lines here, other lines here, other lines here, they are what? They are small circles. But those small circles, they could be smaller than each other, right? But the only one we call the great circle is what? Is those ones that what? That has the original radius as the what? As the like the largest radius of the globe. Now, just consider this very picture. You can see by the left side here at the top. You see that what the watermelon is actually divided into what you can actually see that what it has been divided into what two equal parts. So that means it has been. If you check very well, you see that what it is divided into two equal parts. So that means this very side will be what would be a side on its own, and this very side also will be a side on its own. So that means it has been divided from what from the equator for it to have what equal side here and an equal side here. So at the top and an equal side at the what at the bottom. So because we divided into what two equal parts, I tell you that very side that we divided it is called the equator. And it's what you would actually see if you check that very watermelon to see some of the things that are there, the fruits that are there. You see that what the circle you will see in that very watermelon will be what will be a great circle. Do you understand? But talking about the other ones here, let me use color green now. The other ones here, these small circles you can see here. If you actually cut, let me just try to imagine this place to be a watermelon. Now, if you cut that very top, or okay, imagine it to be an orange. I know everybody drinks an orange, right? So now imagine it to be an orange. Now cut the cap. You know the size you used to give your siblings, maybe your younger brother. If you have to divide that very orange. So if you divide that very top, you know what you would actually see a small circle. This very top here, something like this very top here, you actually see a small circle. If you divide this very line here, just like a line of latitude, if you cut that very orange in that very side, you see that if you check that very orange, you see a small circle compared to when you cut it from the middle. So the only line of latitude that is actually a great circle is it's the equator. So that's what we've gotten one great circle like that, right? So we also have longitude, right? The lines of longitude. So these very lines of longitude, I was telling you the other time that it runs from this very north to to the south. Just like this you can see here. Just like this you can see here. And I was also telling you that it could also be called meridians. So now these very lines, I want to tell you that all of these very lines, no matter how you cut that very line, the very lines, they would actually give you a great circle. They would give you a great circle. So note that all the lines of longitude would give you a great circle, but only equator would give you a great circle in the lines of latitude. If you need videos on any topic, don't hesitate to tell me in the comment section. I'll see if I can make a video on it, just like I make this. Now, this is the part you've been waiting for. How to calculate distance between a small circle. It could be a small circle, it could be a great circle. Now, to calculate distance, this is the formula. If you are talking about a small circle right now, it is theta over 360 times 2 pi r. Now this very 2 pi r, you can rewrite it as like this very r here, it means r. This very the small r means r, like it means big R cos. So have you seen it right now? So this is the meaning of this is the meaning. This is how to get the distance between the small circle. Let me write a small circle here. Small circle. Please jot it down. Small circle. It's important. It's very, very important. Small circle. Now, because we have small circle here, that's why you can actually see a small alphabet here, so that you can understand it. And I will tell you what this means later. But let's continue. Let's continue with the big circle, the great circle. So we're talking about the great circle. This is how you calculate it. You calculate it with theta over 360 times. Now you would write 2 pi. Now the big R. So that's the big R. So now this one is you see that the great circle has big R, right? While the small circle has small r. Now let me explain these terms. Okay, let me write it there that it's a great circle. So that anytime you come back to check this very video, or you screenshot it, you'll be able to understand it very well. Now, that's a great circle, right? So that's the formula to calculate the distance of a great circle. Now, this very theta here is what? Is the difference between their angles. The difference in between the angles of that 2 points. Do you understand? The other one I was calculating the other time, that I was telling you that if it is east, like if a point is in east and a point is also in east, you have to what? You have to subtract. If you have east and west, you have to what? You have to add things like that. So this is where we are going to put the angle. Now we are talking about this very R. The R here, it's a small circle, right? And I explained that the radius of the small circle at that time will be what? Smaller than the radius of the great circle, right? Now we've actually gotten the radius of the earth to be a specified amount. That's actually some people will call it some other thing. Why? But in Waec normally give 6,400 kilometers as the radius of the earth. That's 6,000. Let me write it down so that if you screenshot it, you will be able to understand. 6,400 kilometers. That's what? That's the radius of the what? Of the great circle. Now, for you to now get the radius of that what? Of the small circle, you have to what? You have to look for the cos of the latitude of that circle. Now, I was telling you that if you have something like this, if you have a latitude like this, it could be a latitude of maybe 60 degrees north. Do you understand? Just an assumption, 60 degrees north. So that means you have to what? This very 60 degrees north, you have to what? You have to write it to be what? This very R will be what? The radius of the earth, the normal radius of the great circle. That one will be, if you want to write it like that, you would have to write something like this: 6,400 kilometers now times cos what? Times cos what? What's the latitude? What's that very latitude? The latitude I said, let's assume the latitude to be 60 degrees north, right? So you write cos 60. So that would enable you to get the radius of that small circle. Do you understand? Please understand this. It would enable you to get the radius of that small circle, and with that you'll be able to get the distance between the 2 points that are on that same latitude. Now, in this term also, this very R will be what? Will be the radius of that what? Of that great circle, because we're actually dealing with what? We're actually dealing with the great circle at this very moment. So we use the normal radius of the circle. Do you understand? The formula we just got for the small circle and the great circle could also be used to get the speed, the average speed in which you would that will be required for you to get to that very distance at a particular time. And so you will be able to what? You use this very thing. You can modify it to suit that very purpose. And the formula of average speed. Let me write it. When we're talking about average speed equals to what? Average speed equals to what? Distance over what? Over time. Now, that means if you're actually talking about this very distance, distance equals to what? Equals to the very formula we talked about the other time. That's pi, like theta over 360 times 2 pi r. Do you understand? So this very one now, if you want to talk about it in terms of that one, it will be what? It will be the average speed. The average speed. Then you'd have to multiply it with what? With the time. So that will be what? That will be the what? That will be the distance. Because in Waec you will see questions, a lot of questions like this. So that means if you're actually talking about the small circle now, let me use small circle as an example. You can actually write it as what? As let me use average speed to be A. So A times, let me use the time also to be T. T equals to, you now write theta over 360 times what? Times 2 what? 2, we have 2 pi what? 2 pi r. That's what? For the small circle, where r is what? Is the big circle cos what? So do you understand that? Before we take some examples, please, I would like you, if you've not done that, to click that like button and also comment some of the things that you would like us to make, because what it encourages to do more. Now let's take some Waec past questions so that what we've learned will be well understood. Now this very question I got it from what 1997. That's the 15th OBJ question you will see in 1997. Now it goes thus: 2 points P and Q are what are on longitude 67 degree west. Their latitude differ by 90 degrees. Now we are told to calculate their distance apart in terms of pi. So we are now told to take our radius of the earth to be what 6,400 kilometers. As you can see, I already told you that Waec would give you the radius of the earth to be what 6,400 kilometers, and that's exactly what you can actually see here. Now, after you've known this, what we are just going to do is to draw a diagram. But normally, you don't really need to draw a diagram. But because you are still learning it, I'm telling you, you just draw the diagram so that you understand it better. And with time, you would do what? You would stop drawing the diagram and just seeing the question, you'll be able to what? This is the answer. This is the answer. Do you understand? Now let's draw the diagram. This is the what? This is the globe. Let me draw the globe. So now after we've drawn the globe, let's locate the center. Let's call this the center. Now after we've located the center, we are going to what? Locate longitude 67 degree west also. When we're talking about west is around this side, and we have east also around this very side. Do you understand? So that means that what? Our 67 degree west will be around this very side. Now don't forget what I said the other time. I said what? I said the longitude would go towards the north. Like it's an imaginary line that goes towards the north, to the south, from the north to the south, from the north pole to the south pole. So exactly what I did here. You understand? Now, if you check this very thing, you see that what their latitude differ by what 90 degrees. That means I don't want to know if the first latitude is what it's 40 degrees east, 40 degrees north, and then the others something 50 degrees west, for me to get my answer. I don't want to know, but the difference between their latitude, it could be the latitude could be somewhere around this side. I want you to understand this. The latitude could be somewhere around this side, somewhere around this side, and at the same time, let me draw another circle so that you understand this concept. And the same thing, the latitude could be somewhere around this side again. Okay, let me draw the center. The latitude could be somewhere here and somewhere here, but the difference between the latitude must be what? Must be 90 degrees. That means I'm coming. So that means, okay, the line that will be drawn from this very center of the circle to this very place, the angle would always give me what? Would always give me 90 degrees. Just as you can see here, you see 90 degrees here. That will separate the latitude. But what? The points are what? On the longitude. Just like you can see here also, if you check this very place also, what this question is trying to tell us is that what? The difference between them must be what? Must be 90 degrees. We are not really told where the latitude are. Do you understand? So after we've gotten that, the next thing we are going to do is to calculate the distance. And don't forget, this very thing, as you can see, it's along the longitude, right? And I already told you that when you're calculating something along the lines of or of a great circle, it will be there's a formula for that already. So it is that very formula that we would use to calculate this, because what? It is along the lines of longitude, and you already understood that longitude, like when I'm talking about longitudes are what? Are great circles. That is theta over 360 times what? Times 2 pi r, right? And we are actually told to leave our answer in terms of what? In terms of pi. Do you understand? In terms of pi. So that means we will not actually substitute anything for that very pi. So what's theta? The theta is what? The difference between the latitude is what? Is 90 degrees. So we'll write 90. We'll put 90 degrees over what? Over 360, right? So we'll put 360 degrees. Now, after that, we'll multiply with what? What do we multiply with? 2 And we also have what? We also have what here? We also have pi. So we will not substitute our pi at all because we are told to leave our answer in terms of pi. So we would what? We would put the radius of the earth to be 6,400 kilometers. No, after this, this very 90, we can actually cut it 1 year, 90 year 1, 90 year 4, right? So 4 year 1, 4 year 2, 4 year 1. So that means we are left with what? We are left with this. Let me write it out. We are left with 6,400 pi over what? Over 2. After you've gotten this, the next thing we are going to just do is to what? Is to divide this 2 year 1 and 2 year 3,000, 3,200 what? Pi. That's pi in kilometers. So our answer would be what? Our answer would be option C. You see, these very questions, they are very, very simple, but you need to understand the formulas and the terminologies used to get the answer. Question number 2. Two towns X and Y, both on latitude 60 degrees south, has longitude 27 degree east and what? 33 degree west, respectively. So find the nearest kilometers, the distance between X and Y measured along with what? Along with the parallel of latitude. Now we are told to take our pi, like we take 2 pi r equals to as what? 4 times 10 raised to power 4 kilometers, where r is the radius of what? Of the earth. So because we've actually gotten this, we've been given this, let's now draw the what? Diagram, so that we understand the question and we'll know if it's what? The formula of a great circle that we'll use, or the formula of a small circle. Now to draw a very circle, this is the circle. Let me draw it. This is the globe. Now after I've drawn the globe, now we have what? We have the center of that very globe here. Now after we've known the center of the very globe, the next thing is for us to what? Is to look at them. Okay, 2 points X and Y. Okay, on latitude 60 degrees south, right? We have south and we have north. Just like I told you the other time, that what? South will be somewhere here, and we would have what? Would have north around this very side. So after we've known that, we would what? That means our 60 degrees south must be somewhere around this side. Somewhere around this side. Do you understand? So after we've gotten the 60 degrees south, right? So you can just write it out there, 60 degrees south. 60 degrees south. Now, after we've gotten that, we'll look at the longitude. That's 27 degree east, right? And I already told you that what? East. This is where we can actually talk about east, and we have west here, right? So the east will be 27 degree east. So it will be around this very side. It will be around this very side. The line of longitude will go towards the north, to the south pole. Okay, so that's the what? That's the east, right? So let's look for 33 degree west as well. So the west, 33 degree west. This is west, right? This is west here. So let's look for 33 degree west. 33 degree west around this side as well. Now let's look for what? Let's look for the distance between these very 2 points. That is this very point here. I want to show you. I'm coming on. The very point here, the very point you can see here, and the very point you can see here, the distance between them. Now, before we can get the distance, don't forget that we are going to look for the angle between them, and that is the angle from what? The center of this very circle, this very globe. So that's the angle here. I told you the other time that if you have different what? If you have different like now west, this is west, right? This is east. So we have to what? We will have to add them together. So just like you can see here also, it's very sure that what? We must add them. So just add these very angles 27 and 33 to get the difference between the angles. Now if you add these very 27 and 33, you will get what? You will get your answer to be 60 degrees. So write that 60 degrees somewhere. Now we are going to use this very 60 degrees in our formula right now. Now we are told that what? It is what? Okay. Both latitude, that means they have the same latitude now, and this very latitude, I told you that the only latitude that what? There is a great circle is what? Is the one at the equator, and this one is not the one at the equator at all. I tell you, this latitude is what? It has a smaller radius. That means it's a small circle. That is exactly what they are trying to test in this very question. I will tell you the reason why I said this. So you can see the options here. So we will see if you use the great circle. I'm telling you, if you use this great circle formula, there's an answer in this very question, in this very option. And if you use the small circle formula, there's an answer in this very option also. So they actually want to test if you understand how to this very small circle concept and the what great circle concept. So after you've done this, the next thing we are going to do now is to what is to just substitute our value into the that's theta over what over 360 times we have 2, we have what times pi times, I was telling you the other time that you use small r. Now, and that very small r equals to what? The small r equals to what? R cos what? R cos alpha. Now, you have to write it here. If you substitute this very value into this very place, you would have what? You would have the theta, it will be what? Theta over 360, theta over 360 times what? Times 2 what? 2 times pi times what? That big R. Now you would have what? You would have cos what? Cos alpha. Do you understand? Now with this, you know that what we can just substitute this very value into it. We can just substitute this very value into it. So that's 2 pi r, right? This very place, we will substitute the value of that 2 pi r into it. And we'll substitute the value of theta. That's the difference of the very angle we got now. That's 60 degrees we got the other time. Now let's do that. That would be what? That would be 60 degrees over 360 times what? Times that 2 pi r is we've already been given as 4 times what? 4 times I'm coming on 4 times what? 4 times 10 raised to power 4 kilometers, right? So times what? Times this very cos theta. This very cos theta. Now, if you do that, you would have what? If you can actually cancel this very 60 here, right? So that would be what? 60 would cancel here 1, and this 60 would give you 60 here. So with that, you can actually rewrite this, and okay, that cos theta, that cos alpha is not even cos theta. I'm sorry, it's what? Cos alpha. Now this very cos alpha, it's what? It's what? It's cos what? It's cos 60 degrees, just like you can see here, the cos of this very latitude. Now, if you try the other very cos 60 degrees, it will give you what? 0.5. So that means you would what? Multiply, you would what? You would solve 4 times 10 raised to power 4 over what? Over 60 times what? Times 0.5. Now, if you try your calculator, you will get the answer to be what? To be 3,333 point 3333 what? Kilometers. So that means our answer in this very question is what? It's E. Now I want to tell you that if you actually try the second formula, that's the second formula for what? For the what? Great circle, you would actually get this very answer. That's D. Just try it. You will get this very answer. That's D. And you know that D is not correct. So what I was telling you the other time that if you don't really understand these concepts, you might speak the answer to be what? To be D. But the answer is not D. The answer is what? The answer is E. So E is the correct answer. Let me mark it. Now, before I continue, I've actually done for the 45-minute video on indices. That is actually based on what? Waec Past Questions. If you actually would like to watch that very video, you can click the card you can see on the screen right now. Question number 3. Two places X and Y on the equator are on longitude 67 degree east and 123 degree east respectively. So number 1, what is the distance between them along the equator? Number 2, how far is X from what? From the North Pole. Now, we are being given the pi to be 22/7 and the radius of the earth, just like I said the other time, like Waec used to give us 6,400 kilometers. Now, this is a theory question from what? 2000, year 2000. That's 13, like the theory question 13A in what? In year 2000. Now, let's do the diagram. This is the diagram, right? So, after we've done that, the next thing we are going to look at is what? The longitude of 67 degree east and 123 degree east. Then would have our 67 degrees east to be somewhere somewhere here. I would have our 123 degrees east to be somewhere here. Now we have what? We have it along the what? Like if you can see here, you see what on the equator, right? So don't forget that when we're talking about the equator, it's what? It's actually a line of latitude. But that very line of latitude, what divides this very sphere into what? Into two equal parts. Now, I want to tell you that what I'm talking about this, the distance you're actually looking for now. You know, what is the distance along the equator, right? It's what? It's from this very point here to this very point here. So, how would we get that? I want to tell you that what we are talking about the equator, though it's along what this very thing is along the what the latitude, right? But we will not actually use the small circle formula. We'll use the great circle formula because an equator is what is a great circle. You know, that's the exact thing I was telling you the other time. So let's just write the formula for a great circle here, and that's theta over 360 times what? Times 2 times what? Times pi times what? Times r. So after we've written that, what we are going to do now is what? Is to write the theta. Oh, okay. For us to get the distance between the difference between this 67 degrees east and 123 degrees east, that's what? The difference between this very angle is what? We have 56 degrees. That's 56 degrees. If you check it, you know, we have east, it right? We will subtract. So just write 56 degree east here. 56 degree over 360. Now multiply it by what? Multiply it by 2 and by 22 over 7. No, we've been given pi to be 22 over 7, and the radius of the earth we've been given to be 6,400 kilometers. Now after this, we'll divide through. So that's what. Let's divide this very okay. If you actually divide it and try to get the very answer, the answer you would get will be what? Will be, let me write just the answer so that I will not waste time. And just try to do it on your own. That's 6,200 and what? And 57.7 kilometers. And if you also try to what? To just get the nearest kilometer of this, you can get what? Get your answer to be 6,258 kilometers. So that means don't forget to put kilometers, so especially in theory questions. It will cost you your mark. So that very kilometers now, you see that what we've gotten the answer of I. So let's just write it here. The answer is what? 6,258 kilometers. Now let's move to the second one here. Now, to get this number two, the what you can see here is what? How far is X from what? The North Pole. Now, I want to tell you that X from the North Pole, you know, this is the what? This is X, right? The first one is X. That's the one that has 67 degrees east, right? So, from this very place to the North Pole here, this very North Pole here, you can see here, it's what? It's 90 degrees. 90 degrees. So, note that. That means if you actually want to look for this very thing, it is what? It is along the line of what? The lines of longitude. You know, this very 67 degrees east, it's what? It's a longitude, right? And we'll use that very line to what? To trace it back to the north pole. We'll look for a distance to the North Pole. So it's the very lines are what? They are on this very longitude, 67 degrees. You have X on 67 degrees, and you have the point also on the North Pole also on 67 degrees. And you know that very 67 degrees, it is what? It's what? It's a great circle because it's a line of longitude. So that means for the formula we're going to use in this very question will be what? Theta over what? Over 360 times. Now we'll put what? We'll put 2 times what? Times pi times what? Times what's r? What are we going to put? Is it big R or small r? It's big R. So now let's look for it. I mean the distance there. So that will be what? That will be 90 degrees over what? Over 360 degrees. Now we multiply this by what? We multiply it by 2. Multiply by pi. Pi is 22 over 7. Now you multiply it by what? By r. What's the r? You've already been given r to be 6,400 kilometers. And with this, if you actually try it, okay, you can actually cut this. Okay, let me use another color. So you can actually cut this to give you 1 year, and you use 1 year 4. Do you understand? Now you can actually use this also to be what? To be okay. Let's just write it, and okay, you can actually cut this very 4. You give it 2, and this also would give you what? Would give you 1 year, and this very 2 also, it can cut this very 1, and then this very can also cancel this to be 11. So that we are left with what? 11 times 6,400 kilometers over what? Over 7. Now, if you try this, you would get this very value. If you try your calculator, you get this very value. That's 6,000. I said 6,000. That will be what? That will be 10,000 57 kilometers. 57 kilometers. Don't forget to add kilometers. It's very, very essential. Now we've gotten the answer. I will encourage you to treat more questions on this very words, on this very longitude and latitude. I also upload more videos that would help you on this very longitude and latitude. That will be purely on past questions. But the main thing is that I would like to solve what we mean by longitude and latitude. That's the exact thing I was treating the other time. And thank God, I hope someone should have gotten the concept now. So the next thing we are going to do is to treat a lot of past questions on longitude and latitude. Please, if this is your first time here, please kindly click the red subscribe button and the notification bell to join us as we solve more questions like this. I'm planning on uploading more videos before next week that would help you to pass your exams this year. If you want videos to be made on a particular topic like this, you can tell me in the comment section. Do you need more videos like this? Click and watch the videos that is in the big card you can see on the screen right now. If you've not subscribed, please intensify your efforts by clicking the red subscribe button and also click the notification bell. Don't also forget to invite your friends so that they will also gain from this very channel. On this positive note, don't forget the name of this very channel is what? Do you know? AGF.